So let us go through all the voltage sources first. So in second step, I'm going to say that consider 10 volts active. So if 10 volts voltage source is active, I will replace the other sources. That means this 6 volt will be now short circuited. The current source, like the previous case, will still remain open circuit, and this time we will consider the second voltage source, which is 10 volts. This is my point A and this is point B. So this time let us define this voltage VAB as VAB2, because this is due to the second source. Now the resistance remains as it is. Once again we'll use the same approach to calculate VAB. To find VAB, in this case it's VAB2, I start from point B and travel up to point A. So once again I can follow a very much similar path. This time I come across this 10 volts battery, so going from negative to positive terminal, it becomes 10 volts, and later on there's a short circuit branch, so I do not come across any other voltage. I reach point A, so that becomes my VAB2. Without any calculations, it becomes equal to 10 volts. And finally, let's go through one last step here, step number 3, where we will consider 5 amperes active. So when I consider 5 amperes active, I'm going to replace the other sources. Other sources are voltage sources, so both will be short circuited and 5 amperes will remain in the circuit. So this is my 5 ampere current source, and you can see I have short circuited 2 voltage sources. This is my point A, this is my point B. Now if you observe carefully, this time my resistance remains as it is. The current source of 5 amperes is also present, but my approach does not change. To calculate VAB, this time I'm going to call it VAB3. To calculate VAB3, I'll have to travel from point B to A. So if I do that, I can choose any path I want. There is no point in going through current source because you can't define the voltage directly. It's not that you can't find it out, but we avoid a path that contains a current source. This is the path I'm going to follow once again, and you can see that this time you come across no voltage to define VAB, no resistance, no source, so no voltage that we have to collect as we travel through point B to A. So VAB3 will simply be equal to 0. And hence, because I've got all the 3 values, VAB 1, 2 and 3, I can now quickly define my final voltage VAB. According to superposition theorem, it will be sum of all the 3 values, and therefore VAB is equal to 16 volts. So that's the final answer.